Myself, Sindhu Rekha, working as an assistant professor from Department of ECE in Mlritm Engineering College. Today, I am going to discuss about the subject is Embedded System Design. Final year students having this subject in the semester of first sem. Prerequisites of this subject is MPMC. So MPMC subject they learned in the third year first semester. So today I am going to teach the topic name is Introduction to Embedded System. So next outline of my presentation is course outcomes, syllabus and definition of embedded system and advantages of embedded system, and then basic building blocks of embedded system, and then final one is applications of the embedded system. And then coming to the first one is course outcomes. After completion of this course, student will learn the these many course outcomes. In that, first one is understand the process involved in the designing of embedded system, and then second one is learn the basics of operating system and real-time operating systems, and then third one is the understand the type of memories. In that we have RAM memory, ROM memory, flash memory, like that. In that, fourth one is understand the embedded firmware design approaches, and the final one is gain the knowledge on task communication. So in this we have task communication and synchronization techniques. So finally these many course outcomes students will learn after completion of this course. And then coming to the syllabus, so in the first unit totally depends on introduction part. So in this we have definition of the embedded system and what are the differences of embedded system, means what are the differences between general purpose system and embedded system, classifications, what is the purpose of the embedded system, and history, applications, and then quality attributes. In this quality attributes totally depends on the performance and efficiency of the embedded system and safety, security. So this is comes under unit 1. And then coming to the part unit 2. So this is totally depend on core of the embedded system components. In this we have general purpose and domain specific processors. Like general purpose processor is nothing but microprocessor and microcontrollers, and then domain specific processors are best example is DSP processors, means digital signal processor, and then ASICs. So ASIC is nothing but application specific integrated circuit. So these are specially used for the custom task. And then PLDs are used for the logic design implementation, and then COTs means commercial of the self components. By using this we can minimize the cost, designing cost and time. And then coming to the memories, in this memory we have RAM memory, and memory interfaces, and then sensors, actuators, and some of the communication interfaces like USBs and Ethernet, Bluetooth, like that. And then from the third unit, we fully focused on the embedded firmware approaches. In that we have reset circuit, brownout protection circuit, oscillator unit. By using the oscillator unit, we can generate the clock signal for timing operations. So and then real-time clock. By using this real-time clock, we can accurate the time, and then watchdog timer, and some of the embedded firmware approaches and development languages like C and embedded C, and the differences between embedded C and normal C. And coming to the fourth unit, these are basically to RTOS, means real-time operating system. So in this, what is operating system, and then what are the types of operating system includes task, process, threads, like that. And then moreover we have multiprocessing, multitasking, multi-scheduling processes. And then coming to the fifth unit, in this we have task communication and task synchronization techniques. In this we have shared memory, message passage, message queues, shared memory, mutex, mailboxes, and synchronization techniques are based on Linux, introduction part of Linux, Unix, and what are the advantages of Linux, Unix, Windows, so like that. So this is the total 5 units we're going to be discussed. So coming to the first into the subject. So what is system and what is embedded system? What is system? System is nothing but a set of interconnected components are work together to achieve a common goal or function. It contains both hardware and software. So what is the common goal? So I will explain with the example. So watch is a time displaying system to shows the time. All components like that, label, needles, and then battery, dial, all are work together to shows the common goal is nothing but to shows the time. To shows the time, these many units are work together to reach the common goal, that is called system. So what is the final definition of system? System is nothing but a set of all interconnected components are work together to reach a common goal. This is the definition of system. So best example of system is watch. And then coming to the embedded system. So embedded system, embedded is nothing but combination. So embedded system is a combination of both the hardware components and software components. Embedded system is a electronic or electromechanical system which is used to design specific purpose. So best examples of embedded systems are washing machines, ACs, and refrigerators, TVs, like that. So by using the washing machine, only you can use the wash the clothes. By using the AC, cooling purpose. By using the oven, heating purpose. So we can specially designed for only for the specific task. So perform only specific task. That's why this is called embedded system. So these many are the examples of the embedded system. And then characteristics of the embedded system. So to design any embedded system, we need to follow some characteristics. So based on their applications, some of the applications task specific and time specific. Some of them are high efficiency and a high reliability, and some of them are highly stable, and some of them are low cost, and then it requires less power. So coming to the next slide, in this we discuss about the advantages. So embedded system having many advantages. Not only this, but here I mentioned some of them. So in that, first one is small size. The size will be limited and faster to load, and then easy to manage, low cost, and performance is good, and use less resources like memory and microprocess. So at a time we have disadvantages also. So what are the disadvantages? Is nothing but we have troubleshooting problem, and hardware is limited. If you have any to transfer the data from one system to another system, it is very difficult. If any problem is occur, it is restart again and again. So these are the some disadvantages in the embedded system. And then coming to the basic building blocks of the embedded system, in this the first one is input, and second one is the output, and power supply, controller, frequency generator. So these are the main building blocks of the embedded system. I will explain with the example. So this is the output block, input block, and this is the output block. So middle we have controller, and we have some frequency generator. And to start on the system, we need some power supply. So this is the diagram. So this is the basic building diagram of embedded system. Here we can give the input and we can take the output from here. So this controller is the heart of the embedded system. So based on the controller, we can get the output. To on the system, we need some power supply, that will be plus 5 volts and plus 9 volts or plus 12 volts. So here the controller having control unit, RAM memory and ROM memory, and ALU to perform arithmetic and logical unit. So frequency generator having the crystal oscillator. So this crystal oscillator generates some clock pulses to maintain some timing operations. That frequency will be 11.059 into kilohertz frequency. So here you can give the inputs. So the inputs is in the form of sensors, IRs, Bluetooth, touch panels, like that. In the form of these many inputs, we can give the controller, and finally we can get the output here. Output is in the form of LEDs and LCDs and Bluetooth. So this is the main building block of the embedded system. So, and then coming to the applications. So there are many applications in embedded system. So in that, first one is consumer electronics. Best example in consumer electronics is cameras and camcorders, mobile phones. So these are the examples of consumer electronics. And then coming to the second one is household appliances. In our daily uses, we use many embedded applications. So in that, first one is TV, washing machine, ACs, refrigerators. So these are the examples of household appliances. And then third one is home automation and security system. So best example of this is CCTV. And then fire alarms. So these two are the examples of home automation and security system. And then computer peripherals are printers, scanners, fax machines, like this, like that. And then computer networking system. So best examples of computer network systems are network routers, Bluetooth. And then coming to the healthcare. In healthcare, we can take many scans, in that ECG, EEG, like that. And then measurement and instrumentation. So digital CROs and digital multimeters are the best examples of the measurement and instrumentation. And then banking and retail. So banking in retail, you can use the ATM and currency counting machines. Currency counting machines. So these three are the examples of, not only these, many are there, but banking and retail, we mentioned these three. And then final one is card readers. Card readers, we can scan the barcodes and card reading system. So these are the total applications in the embedded system. And then coming to the textbooks and references, the preferred textbook is Shibu KV for introduction to the embedded system, and then go for the MC Grahill. So, and coming to the references, Raj Kamal book is the best option. So go through this, and then thank you.